Hi there, my name is Giulia Lombardi, I come from Italy, and I'm pursuing a doctoral degree at INSA University of Lyon in France under the supervision of Dr. Michele Lach. I'm here to talk about the ENHANCE project, an European training network founded by Horizon 2020 Marie Skłodowska-Curie Actions. I joined the ENHANCE project about a year ago as an early stage researcher. ENHANCE is an interdisciplinary project that involves 13 young PhD researchers with the common aim of developing energy harvester for self-power sensors, which basically translates to powering sensors by means of energy in their surroundings. In the environment surrounding us, in fact, our energy is already available in many forms. For instance, ambient vibrations, thermal energy and radiations, either sunlight radiations or radio frequencies from telecommunications, and so on. But how is it possible to convert these forms of energy into usable electrical energy? By means of transducers. A transducer is a device or an effect that converts energy from one form to another. For instance, piezoelectricity, meaning literally electricity resulting from pressure, or electromagnetism, resulting from the relative movements between a coil and a magnet, are able to exploit mechanical vibrations and produce electricity. Thermoelectric generators can convert the temperature gradients into electricity. Photovoltaic cells can be used to harvest solar energy, and so on. Actually, many energy harvesting technologies are already applied in everyday products. For instance, kinetic wristwatches that use body movements, or even a simple lighter. By pressing the button of the lighter, a piezoelectric crystal inside it will generate small sparks. Then, the spark ignites the flammable gas, causing the flame to come out. Since energy harvesters provide a very small amount of power, this technology is of particular interest for application in wireless sensor networks, used to collect data and automate specific processes, facilitating new technology trends such as the Internet of Things. A wide range of application of wireless sensor networks can be found in many sectors, for instance, in the automotive sector, and this is where the ENHANCE project comes into picture. Our aim is to harvest energies already available in the car, such as heat, vibration, and light, by taking multiple conversion effects. We do this in order to reduce wires and complexity of the car, thus reducing weight and decreasing maintenance cost. The strength of this project is about the collaboration of the students and partners involved. We all come from different backgrounds, and each one of us is giving its contribution on the basis of different tasks for the same target. Energy harvesting is a multidisciplinary field, and so is this project. Material science, mechanical modeling, and smart electronics are all subjects covered by the 13 of us. We can see in fact the ENHANCE project as a puzzle in which each one of us represents a piece of it and gives its contribution to make it as a whole. Particularly, my contribution is about the electronic interface in such energy harvesting systems. I am dealing with two conversion effects, piezoelectricity and electromagnetism. From an electrical point of view, a piezoelectric generator is equivalent to a current source proportional to the vibration velocity connected in parallel with a capacitor, while an ideal electromagnetic generator can be modeled as a velocity-dependent voltage source in series with an inductor. So, seeing these very strong dependencies between the output voltages and the given velocity, several examples of electrical interfaces that reduce the time shift between the voltage and the velocity have been developed. One of these is called the synchronized switch harvesting on an inductor, or simply SSHI, that consists in adding in parallel to the piezoelectric element a switching device and an inductor. Instead of working with a simple inductor, I have replaced it with an electromagnetic system. Actually, practically speaking, I have not replaced the inductor, I have just added a moving magnet. The resulting circuit we obtain can be therefore divided into two subsections, one corresponding to the piezoelectric generator and the second one corresponding to the electromagnetic generator. That is why I have decided to recall the system as synchronized switch harvesting on electromagnetic system. The proper synchronization of the switches allow me to extract the energies available from the two systems at the right time. So let's come back for a moment to the original SSHI interface in order to see what happens and better understand the phenomena. Initially, the piezoelectric element is open-circuited, so that the voltage produced is proportional to the displacement, here displayed in gray. As the displacement reaches a maximum, which corresponds to no velocity in black, the switch is briefly closed, leading to the inversion of the piezo voltage. Once the switch is opened again, the piezoelectric system is again open-circuited until a new maximum is reached. Now, when considering an acting electromagnetic system instead of a simple passive inductor, when a switch is closed, the current produced by the electromagnetic system leads to an increase of the voltage. The enhancement of the voltage inversion, due to the contribution of the electromagnetic generator, thus leads to a gain in terms of harvested energy. Besides the results that I've been achieving so far, the beauty of this project is also about the reallocation. For example, my headquarters, so to speak, the place in which I carry out most of my work, is here in St. Leon at the LGF laboratory. I will then have to spend 4 months at Imperial College of London and then another 6 months at Cedra Technologies in Grenoble, working alongside my fellow ESRs. If you want to know more about the ENHANCE network, visit the ENHANCE website or stay tuned on LinkedIn, Facebook and YouTube. Thank you for watching.